Do we not have audio, or do we just not have Sammy yet?
Good morning, good afternoon, Babak.
There he is.
Good morning, Robert, Rick, and somebody is on the phone.
Good morning, sir.
Sorry, I was on the road. I was got delayed. Do we have any opens before we start the meeting today? So last week we started discussing some of the performance per watt or energy or joule discussion. Any comments or any additional data that you want to discuss today, or we want to go on a regular agenda? Like I have a couple of items I want to get input from the team.
Just switching back to the full app. My machine was frozen when I tried to log in, so I was in on my cell.
Okay. Yeah, Eric, I think we were kind of discussing the performance per joule or performance part discussion last week, right?
Yep.
We do need to start spending some time, but before that, I would like to get a couple of clarification on the sharing the fan and sharing the cooling, some of the metrics. And also we want to look at some of the metrics that is needed for IUE. I was thinking maybe we could use this as working session to review the data. I was asking, is anything, any additional comments on power performance per watt or performance per joule? We said like we want to take an IR to share the published materials. And
yes, yeah.
Right. So if we have anything already team knows, we could spend some time, or we can come back later today or next week. We can discuss that. I'm just kind of reminding. Do you want to have any discussion around the performance per joule today, or we want to do it next week?
Did you get anything sent to you in terms of links to existing proposals?
I have not seen in my Intel mail. I have not looked at my OCP one.
Okay. Yeah, it seems like we may want to structure that conversation a little bit.
Right. Yeah, I think Robert, we were probably not able to join last week, so we were kind of spending some time on the performance for what. One of the thing is, let us first share any materials people know about previous work, and let us kind of look through and summarize it here. Before we can spend a lot of time, we had a lot of good discussion last week. So if we are okay, then I want to spend some time today regarding the how we want to go about solving the performance, resource sharing. We have a resource sharing of PSUs, fans, CDU. And if you are looking at even you can have a heater or other things that the resources are shared. When we are sharing the resources, what we said is, even if you are sharing 3 servers or sharing the fan, then let us say if all the servers are at full power or equivalent power, you can say it's a 1/3 of the power or spend for the fan is goes to that loss for that server. But if it's only one server is running, then all the power consumed by this fan subsystem should be accounted for the server one that is running, not the other server. So we want to put some formula around that, so to make sure that when we apply for either fan or a PSU or a CDU, that will work regardless of which resource that we are trying to share. I put a little bit thought around it. I typed it. Let me fix it here. Then I will go. Max, I should not be using it. So let me probably give a kind of a example, right? So we want to use a factor like, let us say, maybe I think I should type some examples. Example, let us assume there are 4 resources, 4 compute systems with 100 watts each. And let us say you have 2 fans with 10 watts each or something like that that you're going to use. We want to put some factor. We know like if you take each resource, it is consuming power. And if we add all the shared resources, in this case, you have a 4 compute resource, it's sharing 2 fans. So the total power consumed by this the resource compute resources is the total power gone to the compute resource. In total, it is consuming the power comes out of the span subsystem. But we want to put a factor. Each compute system, we can say like how much power is consuming that compute system divided by the total power for the compute system. That is a factor. If we multiply the factor to the fan subsystem, you will get that share, how much share that is used by the compute system that you want to account for. I didn't probably put the wordings here, right? Does it make sense?
Sorry, Sami, I think I'm not clearly understanding your example. Can you once again talk about it? So you have a shared compute system.
So,
and you're
example,
taking the
let's
ratio
make
of-
it clear, right? So, compute 4 compute system with each, let us say, with 10 watts max each. uses 2 fans. Ten watts max each, right? This is the tray that you are kind of trying to take and trying to kind of factor in, right? Let me remove this guy so that it's easier. So I should have even put a picture here. Like we can want to, we can put it, I think.
It may work better to just do like a Yosemite V4.
And the previous one.
No, I'm just saying, pick an OCP spec like Yosemite V4. Then you have pictures of the spec.
I don't have it off the hand, but
let me find it.
Why don't you finish your example meanwhile?
Yeah, I can just put a picture, easy picture here, right?
I mean, even without picture, why don't you finish in words, maybe?
Let me. I want to take 4, that's easier. So this 4 compute trays, think of it, right? It's not a pretty picture here. It is sharing 2 fans. So if you kind of think of it is a fan is behind that is shared. So it does not matter how many fans it's sharing. It is a fan array that is shared by this computer guys, right? So what I'm saying is collection. If this is going to be a collection, right? This is a collection of compute that is sharing the fan. So set of 4 items are sharing the fan. So what we want to really kind of say is the total power going to the fan subsystem is the one we have to kind of start looking, right? Let us say this total power consumed by this subsystem is, let's put some another example here. Total or system 1 is taking 100 watts and total power consumed by systems equal to 100 watts. Then basically like only system 1 is running and the system 2 and 3 and 4 are not running, right? This case.
Okay, yeah.
Correct. So then all the fan power should go to accounted for system 1. Correct. But if you take a case of S1, everything is 100 watts. Just for example, S1 to S4, all consuming 100 watts, then its a factor is 25% each, right? So this total fan power, you should account for 25% goes to S1, 25% goes to S2, so 25% goes to S3, and so on, right? So what I'm saying is the formula is if you take each compute subsystem, say how much power this is consuming, and you have a collection, and for the collection, how much total power is consumed. So basically, like how much power is consumed by this compute system divided by the total power consumed by the other compute system is a factor. Make sense?
Yeah, I think that makes sense. So the question, of course, is what if only 3 of the 4 systems are present? Do the other 3 get charged? Do you change the factor?
Come again, Eric?
Well, so this is the max configuration. What if physically only 3 of the 4 are populated?
It doesn't matter. It's a collection that you going to represent when you are building a what do you call database API, right? It is going to say these guys together is forming. It's a physical connection, right? You're going to say this collection is the one creating the what do you call? It's sharing the fan. If one is not populated, it's still okay. We are not putting the max. We are just saying the collection contains 4 systems and one not present. But still, you can say like total power consumed by this collection, and the whatever the power consumed by that particular subsystem divided by the collection's power consumption. That's what we're going to go out, right?
Right, but that gives us a scenario where if you have a collection that's max 4 and only 3 are present, then you go read the power for the collection. Like here, the fan power, you're going to attribute 25% of it to each of the 3 that are present. You have 25% of the fan power now unattributed.
No. You're going to read for the collection. If one not present, that is going to be counted as 0. You're going to, this factor is how much power is consumed by individual subsystem divided by the total power consumed by the subsystem.
Oh, you're going to calculate.
He's counting the shared resources.
Oh,
You're
you're breaking up.
Sorry. Yeah, sorry about that. I'm in the train. He's counting for what you're asking.
You're right. You're right. This is a dynamic measurement, not a static allocation.
Correct.
Exactly.
Correct.
Yes.
Star fan power consumed by fan power system. Fan collection.
By the way, this form of amortizing the power that comes from the rack for shared resources, this could be done for any shared resource, not specific to this particular configuration.
Correct. I want to get this example right, so that that's what I was trying to say. I was trying to use some wording in this one resource without really saying what resource it is.
There are others who have defined units for this many, many years ago. I think Google had termed the term server usage efficiency, which means that the server part, which is a computer you're talking about, over the rack shared resources. But we don't need to come up with new terms. So.
Yeah. I want to get this formula right. Then we can go and look at the terms actually used by the definitions, right? Because when we try to map it to each one, we are going to say, give me your factor, right? That's what we want to go and say. Put it under each subsystem, right? If it is PSU or the compute system, we are going to say like, give me a factor. Then we can apply the factor, right? But before that, I want to make sure that this accounting, is it okay? Because even this one, if you look at it, it's kind of linear, right? It's not probably a linear, but we are assuming you are dividing equally across the 4 guys, right? But fan may be, when we say 2 fan, 1 fan may be sitting here, 1 might be sitting here. When you turn it on, you might be turning it on only here. It may not be perfect match, but it's a little approximation, right? So if we say power consumed by system divided by total power consumed by system collection multiplied by power consumed by resource collection. So we can say fan or a PSU or a CDU, whatever the resource, right?
Yep.
Then if you look at it, if you plug in any different values, it's kind of linear. That is only drawback, but at least comes to a little closer approximation.
And do we need to characterize what kind of precision we think we have? That's part of the spec.
Right now, I was looking at the spec. I'm getting only precision. Even that is for only power supply. All other things I'm not getting a precision. When you are saying precision, are you talking about when we report? Is it going to be way off, or is it?
Right.
Let's
Do we have plus or minus 5% or plus or minus 10% or plus or minus 2%? Right.
I will make a note. I think when we kind of go and decide that, I think we can decide how we want to communicate that, right? Yeah, what you're saying, if it is not present, what we want to assume. I think that's probably the question we should ask. Precision can be added. Adding a matrix, including in the definition, is not a problem. If that matrix precision is not available, what we want to account for.
Right.
Do we want to say 10% or 5%? If it's unknown, it's kind of anywhere.
Well, yeah, for the power supply, I think there are specs we can fall back on, right? Based on the requirements for compliance.
Right.
For other metrics, I think we'll have to establish, you know, when we read the dynamic power, how accurate that measurement is believed to be, right?
Yeah, I think without putting some guideline on if it is default, what is the precision, people can go anywhere, right? I think that we want to avoid if not present. Yeah, let us. I will include a precision. I think, but I don't want to put it as a required. It's probably optional. If you put a required, people must present it. Or do we want to force them to present it? Like, say, like 10% or 5% they should put.
Yeah, we'll have to think through our methodology here. I think we flag whether it's required or not, and we come make a decision on whether we need to require it. I would be inclined to require it.
Okay.
There's two dimensions to precision too. There's the value you measured, but there's also uncertainty in the time window that you're measuring. So are you measuring this over 1 minute or 62 seconds?
That
that
believe
could affect the numbers.
Correct. So the metrics allows the flexibility, but you are right. When you, because the heat and cooling does not go within a milliseconds, right? It takes some amount of time to go up and down, right?
Yeah, thermal time constants
Right.
are a little bit bigger.
Right.
But power supplies can have pretty good instantaneous jumps, right?
Correct.
Yeah, you have those effects and just the
I-
basic uncertainty. Are you measuring for 60 seconds or 62 seconds? And there's always going to be imprecision there. And one vendor might have a different idea of what's appropriate than another.
Yeah, although I don't
So-
think, I don't think they're returning energy, they're returning power.
That's, yeah, here the thing is you want to return the power, then you can combine them then to get a final energy, right?
So this is a really good conversation. I think what is emerging from this conversation is that metrics may need to be classified in the form of what time scale they need to be measured at. So besides defining metrics, we also need to associate a time scale with a particular metric.
That's true too. Yeah, it's a yes, and also kind of no, it's a at the end when you look at PUE, we are kind of doing a monthly average, right? This is kind of getting that. You're right. You need to have the instantaneous reading. You need to have some info, but when you're trying to combine them over a period of time, then probably it kind of averages out, right? Depending on which particular, what is the time scale for measurement? I think that's correct. Are we talking about hour measurement or minute or whatnot, right? It's depending on what metrics you're looking. Yes. Okay. Anything additional things here? If you guys are okay, I need to kind of reword this one and really put it as a definition for sharing metrics here.
One quick question, probably for Eric. So timescale is fine. But regarding the precision, why are we specifically expecting imprecise numbers here that we want to add a precision indicator?
Because every measurement is imprecise. We just need to know how imprecise.
Right. I mean, that's across the board, like a general idea. Have we sort of done precision metrics with every other measurement we used in like PUE, etc.?
It is in discussions in the potential regulation language, yes.
Sure, but like here in the PUE paper, I had not seen that, or at least I do not remember seeing that. So I'm just wondering, this precision discussion, this is more of a general across the board. Okay, there is probably inaccuracy. This is not specific to shared resource power.
I think, Sriti, if you look at some of the power supply and some of the definition requests, the precision is defined for some resources, not across the board.
Mm-hmm.
The question is, when we are defining it, right? Is it required? I mean, unless we start putting some thought and putting a definition, people will not use it, and it'll be way off, like, right? Some people might represent 20 or 30% way off, or is it okay? If you put a precision, then they bound to put within that range, right?
Sure. What I'm trying to say is that the precision is if we want to put precision, we probably want to put precision in general in all the metric measurements that we are recommending.
Agreed, or at least everywhere that
Yeah.
it applies, yes. And the problem, so the problem that I'm thinking of and trying to navigate here is, so say you do DC power shaving with a battery, and you need to know how much power is actually used with reasonable accuracy, right? Because you have math to do, right? If you don't know the precision of the power estimates, then you have to apply some huge guard band.
Yes, I agreed with that part. I'm just trying to see that this currently seems like there is, because it's a shared resource, there is some dynamics that causes it to be imprecise, which is not what we are saying.
No, it's just when we do a shared resource infrastructure, we need to know the precision with which we're measuring and trying to do math, right?
Sure, for all the power
But
related
we will need
measurements we are
precision on all
recommending, we need,
measurements, whether they're shared resources or not, I think is your point.
yeah,
And
whether
that's-
it's a shared resource or not, irrespective if we want to put precision, it's irrespective of whether it's shared resource or not. Wherever we are recommending power measurements need to be used, we can think about having the precision.
Yeah.
Yep.
So I
With that-
apologize if I break again, but I think that we have two different discussions here. One is what is the metric, which is what we're going to measure, and what is the methodology for measurement, which is how we're going to measure that metric. I think precision and timescale have to do with how we measure
Yes.
something, and the metric is what we measure. We need to distinguish between these two.
Yes, I agree.
Right, and this discussion is about a methodology for how we measure.
Yeah, I think what we were saying is currently like individual resources, power measurements are defined. And the shared resource mechanics are not defined, at least in the red space. But the contributing factor thing is not defined. That's what we are trying to define it here. But overall, we do agree. If you want to put some precision, you want to make sure that it is across the board, wherever you measure the power, that precision need to be reflecting. So that it's consumed properly, right?
Right. And I think that's why Babak was pointing towards how the measurement is done, because that's where all the precision time scale comes in.
Correct.
Yeah, and we actually have this also. So I bring my other, experience in this. So in SDEA, we have divided this into exactly what the metrics are, and then we have a proper description of what the methodologies are separately. And precision, I think, is related to that.
So I think that brings to the next part of the discussion I want to have, the IEE related metrics that we want to start looking at it and see is it all available, is it good enough, or do we need to add anything more? In the past discussions, we kind of gone through like on the power, what are the different things that we need to start looking at it. Then we said also we need to start looking at the ideal power, static and dynamic. And we also set conversion losses. We should start looking at all the different the power converters in the system. And thermal side, we were kind of looking fan power, CDU, what else? And all these items. What I'm kind of proposing or us to take a look at it is, given these discussions we had, can we start looking at each red space definitions that is currently exists and say like what else is additional things needed? So we want to comprehend the IEE related things, right? When we start looking at the fan power, CDU, even PSU, lot of definitions already available, except the ideal power is not available, that we need to go and put the numbers there. But before going the ideal power, I would like the team to start looking at the red space definitions and see if anything else really need to be added. When I started looking at the red space, when I look at power related, I see electrical bus, floor, PDUs, and all the things related to the distribution unit info is available. And also there are metrics. You can query the metrics. I will walk through that in a bit. There are querying metrics. This is a physical info. Then you can query the metrics on each one to get the actual data from that particular device. Then also you have power domains, power equipments. It's more of the whole external to the kind of systems you can think of. Then when you go to the system level, you have a chassis to each power supplies that you could point to that and say like how much power it's consuming by which power supply. And also chassis information provides which particular systems consuming, or it's a collection, right? There's a collection mechanism to say like, yes, one power supply is used by one system, or one power supply used by multiple systems. If there are multiple systems, what are those systems are? That kind of information is available. And I will take to that spec in a minute. Then when we start looking at the thermal side, again, thermal subsystem kind of contains thermal metrics and also fans and heaters, and also has some metrics there. When we are looking at the cooling, we have a CDU, heat exchangers, immersion units, and pumps and pump reservoir filter, all kind of things are there. When I look, some of the things when you are trying to look where is the power information available, it's kind of difficult to find in some places. I think especially in the cooling, I had some problem. What else? All other things seems to be there. I think except that we need to add the SAD metrics that we were discussing. Let me share the document, then it's easier for us to. I want us to walk through that thing and say like, is anything else needed? Let me share the document. So this is looks like it's not. Yeah, it's coming back. This is a Redfish data model published end of the year. It's June, November. That is the latest version. I'm just looking at it here. So if you go to the resource guide, right, there's it's a lot of resources are defined. It's kind of right now it's organized under the like ABC, like ascending order of names. So you may not able to get all the power related in one place, or all the or cooling related in one place, because all depending on how it's named. But let us just probably given, I think the way I took it, right? I took it from here. If you want to look at power, we need to look at these info and flag what additional things are needed. Any comments before I'm walking through this and spending some time to say like, is there anything else needed?
Well, that
Nope, go ahead.
that one had a comment that was deprecated, and it was pointing you to a different metric.
Yeah, so this one is deprecated. I think I started there. I think deprecated, I want to purposely avoid. Let's not spend time there, right?
Yeah, at the top it says go to the power subsystem as the replacement.
The next one. down here. Yeah, this is the one I believe. Did I have it right? Yeah, this is the one starting. So this is a kind of set of URI for the all the power distribution starting points, rack or it can be electrical bus or a floor or all the different items here. In those one, let us just first ignore the all the firmware version and other things, right? I think what we are really interested is power related items. So if you look at in this items here, I'm just scrolling through. If I could probably give you the link. It's posted on the DMT website. There is no power related information in this itself. If you want to get the power related information, what you have to do is you have to go to the URL and see all the different sensors connected there, right? You have a URL here. You have a URL here, URL here. You kind of walk through that, and you can also get the metrics underneath. So now if you go and look at the metrics part, I think that's where I think the important thing for us, except having the collection part, right? So if I go down to the metrics part, this is where you get all the power related information. So you get energy kilowatts, reading, and power in watts consumed. Power factor is another one, like whether you are really like doing watts or milliwatts or whatnot, you can represent. And sensor values. So if you look at this, I think for us, the interesting point is the power that is going to be in watts, right? This is what power consumption information that you are going to get. And it does not have any precision or any of the info that we were discussing, right? It just says power in watts. The question is, do we want to and also it's instantaneous power, right? That's what we represented. If somebody wants to understand over a period of time, that need to be somebody else in upper stack, they need to tell the total consumption, right? And also it has
in the, let's see, in the sensor schema, there are fields called accuracy, the estimated percent error of measured versus actual values, and precision, the number of significant digits in the reading.
And is it a link to this one, Robert?
I'll paste in chat the paper where I see that.
Okay, if the sensor is there, then I think as long as we link to that, then you automatically get that info, right?
It's on page 34. With that link.
So you can link the sensor to every single. So this is. Oh, what you're saying is sensor IDs can be added on every single device. Then you can automatically get some set of metrics along with it.
Yeah, you can associate values, attributes of a sensor type. Yeah.
Okay, then I think we are getting what we wanted.
That's what we would have expected. We're all engineers, right?
That's good. So then I think here what we are kind of looking at. Where are we? I think this is a large file. I think it whenever you scroll through, it does not go properly. Okay. Drop something. Hold on. Sorry, I think it's something happened.
Auto scaling.
Huh?
It's not auto scaling.
Yeah, it's doing something. Let me. I need to close and reopen it back.
We're starting to lose people here at the top of the hour.
Yeah, so I think maybe I would say I will a couple of things, right? I think Babak, you were able to share the link for your email. I will share post this material and send the link to the team. And if you can start to take a look at this schemas and identify is there anything that stands out that's needed specifically for us, flag me in. What I want to do is I want to get this final metrics in and call out what are the new things that we are adding to the next meeting and say like, here we have all the things needed that is present or not. If we need anything more, I would like to send that info to the power and telemetry work group and want to make sure that they are able to comprehend as part of their metrics. What do you guys think? Is that right mechanism, or do we want to spend more time on here?
No, I think it makes sense to try to up level the conversation.
Right. So yeah, let me spend some time offline. I was spending a little bit time, not much time on it, so I didn't have a summary. Maybe I think the best time for this work group is to get summary here and give a next steps. That way, we are not really like spending time in this meeting here to walk through this metrics here.
Right. Well, and I think Robert gave us what we needed here.
Right.
All I was saying is that when we do derive metrics like this, we just have to propagate the accuracy information associated with them.
Right. Good. Yeah. Then I think what we will do is let me I would like to get this closer, probably next week, to a level that we feel comfortable. Then after that, let's start spending time on the performance side. And also, we do need to submit the Global Summit presentation. I think June 21st is the abstraction final due date. Start thinking about what we could present to the Global Summit. At least I see like update to the UE and also the metrics that any new things that we are defining. That may be one topic. Another topic is if we can make progress on the performance related, that may be another things to discuss.
Okay.
Yeah, when we meet next time, let's kind of try to finalize that topics too.
All right.
Thank you, Tim. We'll see you next week.
Thanks, Simon.
Thank you. Bye.